Now we'll talk about our next lab, which is lab 3. Lab 3 is based on the compare and branch instructions. We already have talked about the compare instructions, and at this point we are also working on the branch instructions in our quizzes. So this is the best time to talk about the lab 3. Okay. Now in lab 3 we have several different parts. So in this lecture we'll talk about what exactly we need to know for each part so that we can get it done. Okay. Now the first part is obviously lab 3A. So to understand the lab 3A, what we need to know, I listed all the things that we need to know here. The first thing is identify positive and negative hex bytes. I think we already know how to tell which byte is positive and which byte is negative in hex, right? So anything that starts with 8 or more, that's negative, right, in hex. If the left digit, in case of 1 byte. So we can tell those, right? We'll also talk about the comparative adjectives we use in plain English for comparing signed and unsigned bytes. This is really important to understand because, as I said, a lot of times you have to deal with the plain English description. You have to read the literature. You have to read the instruction given in plain English. So to understand it, you actually have to understand the comparative adjectives. We'll talk about this soon. Okay. We also want to write a couple of lines of instructions so that we can compare numbers using the compare instructions. And just as a quick reminder, I think you have already noticed that we have 3 different compare instructions in our instruction set. One is for A, one is for B, and one is for D, right? Which is CMPA, CMPB, and CPD, right? And we'll also want to write a couple of lines of instruction to branch based on the comparison. And at the end, we also want to see the branch instructions used for signed and unsigned bytes. Now, out of this list, I'm actually opting out the first and last one because the first one you already know how to do it, right? How to identify the positive and negative bytes. So we are not going to discuss that. The last one, we also remember at the very beginning when we first talked about the branch instructions, I actually show you in one slide that we have list of branches which works for unsigned number, some branches work for signed numbers, some branch work for both. So we already know all of these, so I'm not going to go over those again, but we'll talk about the most important ones which are in the middle. Okay. Now let's first talk about the comparative adjectives for comparing signed and unsigned bytes, and this is really important, and make sure we understand it now, which will be extremely useful now and in future. Now, this is all about the plain English wording. So if you are using the numbers that unsigned, remember, you have the freedom to use the number as signed and unsigned. If you're using the number as unsigned, we use some wording like this: lower than or higher than. If I'm comparing two number, and if I'm just saying, okay, for an example here, if I'm just saying, oh, 5E is lower than 9A, then by the lower than, you know that I'm comparing the number as unsigned. Now, how can I tell that 5E is lower? Because whenever you are saying unsigned, that means technically all the numbers are positive numbers, right? There is no sign. So when you count 5E and 9A, actually 5E comes first, right? Think about counting, right? 5E always comes before 9A, that means 5A is lower, right? I'm saying if you think about the unsigned number. But at the same time, if you are comparing both numbers as signed number, you'll be using in plain English lesser than or less than. You know what I'm saying? Instead of saying lower than, you'll be saying less than or lesser than. Now, see, look at the wording. A lot of times, people will not tell, oh, I'm comparing the number as unsigned. Oh, I'm comparing the number as signed. They will just use the word, and you have to understand why they are writing lesser than or why they are writing lower than. This is a little bit tricky. And now think about this. We actually we are trying to still compare the same two numbers, 5A and 5E and 9A, but how we are writing? We are just saying 9A is less than or lesser than 5E. Why is that? Because 9A is a negative number, right? Now this is signed, right? And any negative number is less than any positive number, right? This is really interesting. Think about the numbers. We are comparing 5e and 9a. So both of the statements are true. You can tell, oh, 5a is lower than 9e. I'm sorry, 5e is lower than 9a. And at the same time, you can tell 9a is lesser than 5e. And both of the statements are correct because of the wording. Because when you are saying lower than, you are comparing unsigned. When you are saying less than or lesser than, you are comparing the numbers as signed. And both of the statements are true. Same is for the higher than and greater than. When you are comparing the same two numbers using the higher than wording, that means you are comparing the numbers as unsigned. And obviously you will tell 9a is higher than 5e because 9a always comes later than 5e when you count, right? But when you are comparing a sign using the wording greater than, how do you tell? You will always tell 5e is greater than 9a. Why? Because 5e is a positive number and 9a is a negative number. I'm sure that you are getting excited, right? See how you can pretty much write the same comparison, and it's very interesting. Let me show you a couple of interesting questions here. Now, let's say I have some fill in the blanks here at the bottom. So in the fill in the blanks, I'm actually comparing 7b and 82, right? Can you select which ones are valid for this fill in the blank? Let me give you a hint. There will be two choices. And obviously one choice is for unsigned and one choice is for signed, right? Because in the statement I did not mention whether they are signed or unsigned comparison. So you actually have to select both. So these are the choices, lower and greater. So if I'm comparing the numbers as unsigned, 7b is lower than 82, right? But if I'm comparing the number as signed, 7b is greater than 82. This is really exciting, right? So at the same time, this is lower and greater. Any question? So again, this lecture is from lab 3. If you want to look at the PowerPoint, it's there already, just in case. So let me show you another example. Okay. Now let's say I'm trying to compare 37 and 45. Can you select two comparative adjectives from the list? Remember again, you will select one for unsigned, you will select one for signed. Which are the correct statements? "37 is lower than 45, right? And 37 is also lesser than 45. Why is that? Because when you are comparing the numbers as unsigned, 37 is of course lower than 45 because 37 comes before 45. But when you are comparing the number as signed, 37 is still lesser than 45 because both numbers are positive. As long as both numbers are positive, 37 is always lesser, right? Than 45 because both of the numbers are this time positive. Any question? Okay, let's try another one. How about this one? 87 and 95. "87 is lower than 95, of course, right? How about the sign comparison? 87 is actually greater than 95. Why? Because 87 and 95 both are negative numbers, right? Which is less negative? 87, right? So 87 is actually greater than 95. Just like how the -2 is greater than -5, right?
Yes, yes.
It's really exciting. Do you agree? Okay, so these are the comparative adjectives. And again, I'm sure that you will miss these quiz questions, but don't miss it too much because you will see it again in the pre-lab 3A, okay? So if you understand up to this point, let's try some of the, try to write a couple of lines to compare the numbers. So far you probably have realized that all the comparison instructions that you have, it does the subtraction, right? But it never saves the answer. Sometimes we get confused that what is the point of just doing the subtraction and not storing the difference. There is a point, because if the comparison is designed to have a subtraction and to change the flag, not to save the result. Because when you are comparing the numbers, after subtracting, when the flags are changed, based on the flags, you actually can determine what happened. You don't actually need to save the difference. That's exactly what the comparison does. Now for an example, let's say, how do you compare two bytes? For an example, if somebody give me two bytes like 45 and 86, I'll always do like this. When first line, I'll load one byte into accumulator A. In the second line, I'll just say CMPA, because I'm doing everything in here in accumulator A, I'm doing CMPA 86. So that's how I'm actually comparing 45 and 86. Okay, first byte and second byte. Now, let's make it a little bit extended. Now, let's say if I have to write a third line for my branching, okay? Now, if I'm writing my first byte and second byte, and then if somebody asks me, can you select a branching instruction which will make a branch when the first number is greater than second number? That's exactly what we wrote here, right? First byte is greater than second one. Now, again, first of all, how the number is compared, a signed number or unsigned number? Think about the wording, greater than, right? Is signed, right? Greater than is signed, right? Now, for the greater than, you can find the, remember the description we just showed you in the branch instruction 3 lecture, second slide, we have the list of all the branch description, okay? From there, you know pretty much that it will be BGT, because BGT means branch if greater than. That means if you elaborate, which is already there in the second slide of branch instructions 3 lecture, we said branch if the first byte is greater than the second byte. That means if the first byte is greater than second byte, this will branch. See, it doesn't mean that the first byte is really greater here, but it means that whatever the first byte, if it is greater, this branch will make. And you have to select the branch based on that. And remember, wow is just a label, okay? You can use any label name. That doesn't make any difference as long as you have the label in the program. Okay, let's try another one, okay? Same code, okay? Now let's say if somebody tells me, okay, can you select a branch which will make a branch if the first byte is lower than the second one? Now it is lower, right? So I select BLO, again, is from the list. Branch if lower, that means branch if the first byte is lower than the second byte. And as you can guess from here, we are comparing the number this time as unsigned, right? Wording, lower. Lower means you are comparing as unsigned. If our first byte is lesser or equal to the second one, for lesser and equal, we have another branching, BLE. If you look at the list, you will find it. BLE is used for that, and now you can probably see that we are comparing the number as signed, right? Lesser or equal. So pretty much it will give you an idea that how we can write it. And this one is for greater or equal, BGE. Again, sign comparison, right? Greater. Now, what exactly we are doing in Lab 3A? In the Lab 3A, you will be given a program. It will be given to you, so all you have to do is just type it in, okay? But we also want to make sure we understand it. The reason is, if you don't understand, you cannot modify in the later part, because you'll be just modifying the same code in the later part, okay? So I tried to give you an idea exactly what we are doing in the lab. I'll also show you the code that we have in the Lab 3A, so you understand what you are going to, work on your lab. Okay, this is what exactly we'll do. Your program will request 1 byte from the keyboard, meaning from the user, to the accumulator A. It's loaded, okay? That means it will actually ask you to enter a byte. So you'll be entering a byte. Let's say 2E or 5C or 7A, whatever you want. You enter it in hex. that byte will be saved into accumulator A, okay? And then it will be automatically, that is your first hex byte that you enter. The first hex byte is compared with 6F. You might be wondering, how do you get the 6F? This is just a number we used. It's given. I'm saying it doesn't have to be 6F, but this is how we wrote the program. I'm saying 6F doesn't make any specific meaning. I'm saying it's just a number. Now, we compare it and we do this. If the hex byte that you entered is higher than 6F, be careful, higher than, right? Unsigned comparison. If higher than 6F, it is rejected. Now, what do you mean by rejected? There is actually no way you can reject any number, but this is how you actually reject logically. What you do is, if the byte you entered is higher than 6F, your program will ask for the first byte again. So it will actually keep asking for the first byte again and again as long as you enter anything higher than 6F. So this is an example where you can see that how branch instructions are so important and useful, okay? Because just because of the branching, you can compare any number with the 6F, and if it is higher, you can go back and ask for the same byte again and again, okay? So it's pretty much like you are restricting somebody to enter any number which is not higher than, which is higher than 6F. All right, so when you enter something lower than 6F, the number will be accepted, and what happens is the hex byte is copied to accumulator B. Remember, the hex byte is automatically stored in accumulator A, right? But now you will be taking a second byte in accumulator A, so you save the hex byte from A to B. So hex byte is, so the first byte is saved already in accumulator A. Then what you do is, you similar way you take a second hex byte. So basically you will ask for a second hex byte to user. User will enter the second hex byte, whatever the byte he wants or she wants. Then first and second hex bytes are added and stored into accumulator A. Once the sum is produced, program checks whether the sum is positive. If the sum is positive, program starts over, meaning it goes back to the beginning, asks for another first byte and second byte just the same way. Otherwise, if the sum is negative, because think about this, it's possible the sum is negative, right? If the sum is negative, the programs start over after a beep. So basically, you just hear a beep, okay? Now, to produce the beep, we actually use a subroutine beep. So all the subroutines that you probably will see in our programs, those are not written by Motorola. Those are actually written by us, because there is nothing given in these programs, because these are something very primitive. But remember, in every program, when you start the program, you include a header file, right? Remember the header file, you include cent.h. That is a header file written by us. Inside the header file, we have written plenty of subroutines which actually will help you to, get rid of many primitive programming, okay? And we'll talk about those, subroutines in next semester, okay? Now, let's look at the code again here. So whatever we talked about, in the last slide, we talked about the program. This is actually the program, and the left side of the program, on the right side of the program, I wrote all the comments so that you will exactly understand which line is exactly doing what, okay? So I'm actually asking for the first byte, and then I'm printing the output. Basically, I'm printing this. At the beginning, I'm just saying, oh, enter first byte. The program will wait until you enter a byte. So in the third line, in the JSR get byte, out string, all these are subroutine written in the cent.h file, header file. Get byte basically take an input from the keyboard and store the input into accumulator A, okay? And then you see here, I'm comparing that byte, whatever you have in A, because just the one that you saved into A is compared with the 6F. And then if it is higher, do you see BHI, branch if higher, right? If it is higher, you are going back to a label too high, which is actually here. So you actually are going back to the beginning. That means you are rejecting the byte. So what you are doing is you are going back and then asking for the first byte again. And your program will keep doing the same thing as long as the user doesn't enter anything lower than 6F. But once it is accepted, you go to this line where you copy the first byte to accumulator A from accumulator B. I'm saying accumulator first copy is to B from A, right? and then you start working with the second byte starting from here. You get the prompt, you display enter second byte, and then you take the second byte and you add the first byte and second byte, and then BPL is a branch instruction which just checks whether the result is positive. Whatever the sum you got, if the sum is positive, you go to the start label. Look at the start label, that is exactly at the very beginning, so it actually starts over. Otherwise, meaning if the sum is not positive, you go to the next line because branch doesn't make. You go to the next line and you do a beep. See, this is a subroutine, beep. And this subroutine is again written in cnt.h file, so you don't have to understand the subroutine. All you have to do is just write the beep. It will give you a beep, okay? So it will give you a beep so you'll know exactly what happened. Because if you get a beep, that means your program, your sum is negative. But you still go to the beginning, right? At the end, you see there is an unconditional branch. That means no matter what happens, you go back to the beginning. This is actually a very simple program, but this is the first program that you are having with all the branch and comparisons, okay? Because you see there are plenty of branches. Now, if you got until this point, and if you don't have any question at this point, I'm sure that you'll probably will have any question, you should be ready for our first part of the lab, which is lab 3A. But to understand this part, we want to make sure that we understand the lab and we complete the pre-lab quiz 3A with at least 80%, just like the other pre-labs, okay? We're not done here, because in the second part, which is 3B, we do a little bit of modifications on the first one. So what I did here is I actually blurred everything except the modification part. If you see there's something in purple, do you see the purple writing? Those are the ones which we are modifying. So everything else I copied from the first part. So everything else we already have it here, okay? Now we are doing a little bit of modification. Remember, we took the first byte and we compared the first byte with 6F, right? But we have not done anything for the second byte. But this time, we will compare the second byte with 6F again. But remember, look at the comparison. Second byte is greater than 6F. That means second byte is compared with 6F as a signed number, right? Look at the wording, greater than. And again, in the same way, it is being rejected if the number you entered is greater than 6F. Can you tell me any number which is greater than 6F? Of course, 70, okay? Is 85 greater than 6F? No, because 85 is a negative number. But 85 is higher than 6F, but not greater. Be careful. Okay, now, so if you entered it correctly, second byte is also accepted. So all we are doing here is we are also checking the second byte in addition to first byte, okay? Now, to understand the modification, I tried to give you a list of steps as a hint so that you can do the modification. In the step 1, we identify the block of code that takes the first byte, meaning that is responsible for the first byte. We'll call it block 1. Now, I circle the block just to make sure you can see that these are the lines which are responsible for the byte 1. And we are pretty much done with that byte, right? We are not doing anything new with the first byte. But I still want to make sure we understand the lines of instruction that we have for the first byte. Then we identify the block of code that takes the second byte. Again, this will be called block 2. Now here is my block 2. I circle the block 2 because at this point we just have the lines for the prompt and for getting the second byte. But remember, we'll be adding a couple of lines there, right? So in the step 3, we will add a label at the beginning of the block 2. So we'll actually add a label here. See, I wrote a label here. Now remember, you can use your own label, okay? So you can use a label name there to start with the, to start the block 2. In the 4th step, we add 2 lines of code similar to the last 2 lines of block 1 at the end of block 2, so that block 2 rejects the second byte if it is greater than 6F. So this is exactly what we'll be doing. We'll be adding 2 lines here, see, at the end of the block 2, which will be similar to these two lines. Remember, similar. So that means you actually have to find out what will be the branch instruction. Okay? We are comparing the numbers as greater than, right? We'll be adding 2 more lines here, and we should be done. If I'm sure that you probably will have some question, but if you understand up to this point, you actually should be ready for the second part of the lab, which is just a simple modification on the part 1. Okay? Now, we have a pre-lab for this part, is a separate pre-lab, which is pre-lab 3B. We want to make sure that we understand this part, and we want to finish it with 80% at least, just like the other pre-labs. We are still not done. We have some remaining part. So we have 3C to 3E. So for all this part, we just, these parts are pretty close to each other. So I just, put everything together. So in this part, what we are doing in this program, I actually wrote a lot of comments in the right side. So this is what we do in this program. We first take some characters from the user. User just randomly enters some character. If you enter 40 characters, you will see the program will display 40 asterisk. Okay? This is simple. But the way we do it is, remember, we actually try to track the characters. So this is how we do it. We first load a number 40, because this is just like a loop. Because every time you enter a number, the 40 is decreased by 1. That's what I'm saying. It becomes 39, 38, 36. As long as it is 0, it actually will keep asking for the number. So what you do is you first take a character. This is a subroutine, INCH. Again, written in the header file, which takes a character from the keyboard, meaning it will wait for you to enter the character. And again, we check the character with the compare instruction just to make sure that the character is not less than character C. Now what exactly we are trying to mean? See, this is how we compare the character. Do you see a pound sign here? And do you see after the pound sign there is a small quote? Don't think this is a mistake. The quote would be there because whenever you use a quote and a character, your program assumes that you are trying to write the ASCII number of the C. Because every character has an ASCII number, right? When you just say quote C, your programs know what is the ASCII, because you can find it, of course, but your program knows the character, ASCII. So by this, you are just saying that you cannot enter any character which has a ASCII code less than C. Because if it is less, then your program will actually go back to the beginning. You see, your program will go back to the loop 0. Now, can you tell any character which might have an ASCII code less than C? Uppercase C, might be uppercase A, uppercase B, right? Space bar, because the space bar has an ASCII of 20, which is much lesser than ASCII of C. So you actually have to enter everything which is higher than C, like every small letters, meaning lower cases, D, E, F in higher case, all the way up to Z. I'm saying this is just a tricky part, which you can see that you can restrict some character, right? It's interesting that just writing, and then if it is successfully done, then you display the output. So it's pretty much like this. If you enter like anything lower than C, your program will not even display it. So you might think that your keyboard is locked because it will not display anything. And then it will decrement every time you enter anything, it decrement B. Why it is decrementing B? Remember, B is 40, right, at the beginning, so that it keeps track of the character you are entering. And then every time it's checking whether the B becomes 0, meaning whatever you have in B is 0, because if B is not 0, then it goes back to the beginning, X for the character again. Whenever the B is 0, it goes to the next line, and then out Control F actually moves the character to the next line, and then again you run a loop, and then you print 40 character, 40 asterisk. See, this is 40, and then you actually display 40 character, and this is the output, and you'll see the rest of the lines. So I tried to make it a little bit simple, but in the later parts, you actually have to modify it. So to do those modifications, let me show you a couple of hints so that you understand the modifications. Now, this is what we'll be doing in those modifications. We will restrict some character to display. So for an example, how can you restrict a character like character D to display? That means if you write these 4 lines of code, what happens is this. your character, meaning your keyboard, if you type anything in the keyboard, it will display it except small d. There is no way you can display small d. Why? Look at this, why? Because at the beginning you are just saying, can you enter a character? You entered a character, right? And your character is compared with the d, small d. If it is d, that means if it is equal to d, you are going back to the beginning. You are not even displaying the character. But if it is something else, then you go to the line number 4 and you are displaying it. So it might look like that if your keyboard is not working because your D is not displayed. This is a really powerful line of code. Think about this. High level language is impossible. But in the low level language, just using something like this, you can in fact block almost like half of the keyboard. And think about how simple it is. If you run this program as a scripting, just like a virus, your keyboard will not even working. And you might be thinking, oh, my keyboard is gone. I'm saying it's actually working, but you will not be able to see any character. You can even do better than this. For an example, if you want to restrict a range of character instead of just one character, you can do it just writing the same 4 lines with a different branching. Right now, we just wrote BLO. That means if you enter anything which is less than T, now what do you mean by less than T? Meaning which has ASCII code less than capital T, then it will not display it. A lot of characters are restricted, right? If you do this. So I'm just showing you that just writing the same 4 lines, you can even block a lot of codes if you want. Now, I even tried to give you a list of steps here for these 4 lines, that how you can write these 4 lines to restrict the characters. For an example, a lot of times what you do is you might have multiple character to restrict. Instead of range of character, instead of a single character, you might be just restricting capital A or capital M or capital G, let's say. Okay? So how do you do it? You do the same. You start with a label and you call the subroutine INCH. How do you call a subroutine? You write JSR INCH, right? JSR is for calling the subroutine, jump to subroutine. Okay? We always use JSR when you call a subroutine. In the second line, you compare, just like how you compare, right, with a character. In the third line, you select a branch. So most likely you know what branch you need to select. And then for every character you are trying to block, you actually have to repeat the line number 2 and line number 3. Because it's possible that you might be blocking more than one character. And those characters are random characters, not false in a range of characters. You know what I'm saying? It might be capital A or capital O or capital P, for an example. Okay? And the last line is always just printing the output by calling the output subroutine. Because last line means this, you block this character, and if you enter something else, then it will be displayed. Okay? So you can do pretty much the same thing. So you can even do the backward thing. For an example, if you want somebody to only display the character you are entering, that means, let's say you said, okay, I want somebody only can display the character J, nothing else, from the whole keyboard. Just by writing these lines of code in 4 keyboard, you will be able to only print only one character, nothing else. Think about how powerful it is. Just writing 4 lines, you are blocking the whole keyboard except one character. Okay? The only thing is tricky part is line number 3, because in line number 3, we actually have to write a different branching. So I'm not going at a lot of details on the branching at this point, because this is like a hint. So you have the list of branches, you have all the descriptions. It will be exciting to find the branch and play around and find it, okay? So that's why I'm not telling you exactly what will be the branch. And of course you'll know what will be the branch, but this is an extensive, the hints that I can give. So I'm hoping that we pretty much understand most of it, but again, at the same time, this is also true that once you complete the pre-lab A, 3A, and 3B, you'll understand the pre-lab 3C much better than now, okay? So I'll hold your question until that point, and I'm sure that you'll probably have questions. We'll answer it at the time you do the quiz. So, and again, for the all the last part, we have one single pre-lab, which is 3C. So basically, we will be working on 3 pre-lab for the lab 3, 3A, 3B, and 3C. We want to complete all the pre-labs with 80% to start the lab, okay? So let me stop our presentation here so that we can work on our quizzes and pre-labs.